When it comes to LED stage mapping, an LED processor usually takes a single video input and divides this signal over the connected LED walls. For example, to set up a single LED screen is pretty simple. The processor takes the top left part of the video signal and displays it on the LED wall or panel. Let's say your LED wall is 384 by 192 in resolution. The output your processor expects would look something like this. The processor will only use the top left part from a video signal. For this example, let's assume the video signal is 1024 by 768. The processor is only interested in the 384 by 192 section of pixels in the top left of the 1024 by 768 signal. The rest is not used. You could render all content to this scale before a show, but the flexibility of advanced output makes the process easier. Let's show how this is done in Resolume Arena. Here's a composition with the size set to 1024 by 768. Go to the Advanced Output settings and click on the Output Transformation tab. Make the size of your slice 384 by 192 pixels by editing the values directly on the right. If you haven't, be sure to toggle snapping by clicking on the magnet icon. Now position the slice exactly in the top left to match the specifications of the LED processor. Now let's click on the Input Selection tab and then right-click on our slice. Select the Match Output Shape option. This will place your slice exactly in the same position as the output transformation. Position the selection towards the center and snap it into place. By holding Option or Alt-Shift together, scale the selection until it fills the width of the input viewport. If we switch back to the output transformation, we can see that the slice now uses much more of our content from the composition and places it in the top left of the output where the LED processor can use it. By matching the output shape, we've made sure our input slice uses the same aspect ratio as the output shape. The top and bottom will be cropped, but at least circles and other shapes will display correctly on the LED wall. Let's discuss the process for a more complex situation with the 4-screen LED wall. Imagine your stage looks like this. Unfortunately, the 4 screens are positioned like that on stage, but not in the LED processor. In the LED processor, the arrangement may be similar to this image. This minimizes the data sent along the cable connecting the LED screens. 4 screens like this are still controlled by a single LED processor. Only one signal from your computer's output needs to be sent out. The processor divides it over 4 screens. For a 4-screen LED setup, you would need to recreate the 4 slices in the Advanced Output settings. Here in the Output Transformation, we've already configured and positioned each slice according to LED processor specifications. By doing this, each slice will be displayed on its designated LED screen or panel. An LED supplier can give you this output mapping before a show. With that information, you could simply enter all the values for each slice and organize the slices beforehand. Under Input Selection, select all slices, right-click, and select Match Output Shape to retain the general shape and aspect ratio of each slice to be used in input mapping. The 4 slices will be positioned exactly the same way as they are in the output transformation. Now what we can do is roughly position each slice according to our original stage setup, just like the photo. To use a photo as reference, click on Screen 1 in the left menu, and under Input Guide on the right menu, select Load. Now you can lay out the slices similar to how they are placed on the actual stage. Although we can use a tape measure and estimate distance, it's all about selling the illusion to the crowd, so it doesn't matter if you're a few pixels off. Once you're satisfied with the layout, select all the slices and scale everything up to fill the width of the input viewport. Do this by holding Option or Alt-Shift and dragging the corner points. Now your content will translate perfectly to the LED wall. If you would like to trigger content onto specific LED screens or panels on the physical stage, you can do so with the Slice Transform effect. Let's show how this works. First, let's clear the content from Layer 1. We currently have the Slice Transform effect applied to Layer 2 and Layer 3. Notice when we trigger a clip on Layer 3, content is displayed in the center screen. This is because the slice we made in Advanced Output is being displayed using the Slice Transform effect. To do this, make sure you can view slices by clicking on the View menu and Show Slices. From the Slices panel, simply drag any slice to the Slices parameter under the Slice Transform effect. By triggering a clip on layer 2, notice that the content is mirrored and displayed on wings of the stage. This is because under the Slice Transform effect, the slices mapped to the wings are being used by this layer. We're able to mirror the content by using the Pac-Man icon to designate the orientation of the slices. This is a simple solution to have more control over the content displayed on the various screens of our stage. By using this method, you could create more complex setups with multiple layers and effects to make a stage more engaging than ever.